A factory produces item X and item Y. The time that it takes to make parts for item X is 4 hours, and for assembly is 3 hours per item. The time it takes to make parts for item Y is 4 hours per item, and assembly is 6 hours per item. The factory has designated at most 36 hours to make parts and at most 30 hours for assembly. If item X generates profit of $90 per item and Y generates a profit of $110 per item, maximize the profit. So since we're trying to maximize the profit function here is the equation that will be optimized. So that is our Z equation for the linear programming problem. So the profit we'll call Z. That's going to be equal to $90 per item for item X, so 90X, plus $110 per item for item Y, so 110Y. This is the function that we're going to try to maximize. And now we write the system of inequalities that go with this function. So our inequalities have to do with the production time. One of them is going to have to do with the production time for parts, which is at most 36 hours. At most means that it's less than or equal to 36 hours. And then the other equation is going to have to do with the assembly time, which is at most, again, less than or equal to 30 hours for assembly. So now the assembly time for X is 3 hours and the parts time is 4 hours. So let's start with the parts equation. Parts for X is 4 hours per item, so 4X. And then we're going to also use parts for Y. Parts for item Y is also 4 hours per item. So 4X plus 4Y is the time spent making parts. And that is at most 36 hours, so less than or equal to 36. So now the assembly for X is 3 hours per item. So 3 times the number of X items made. And assembly for Y is 6 hours per item. So plus 6 times Y. And that is at most 30 hours, so less than or equal to 30. And then we have two other equations that just force both of these quantities to be positive because we can't make a negative number of item X or a negative number of item Y. So our other two equations are X is greater than or equal to 0 and Y is greater than or equal to 0. So now we start graphing our system of inequalities in order to solve this linear programming problem. So starting with that first inequality, we do want to transform it into slope-intercept form. So we'll rewrite it. 4x plus 4y is less than or equal to 36. We subtract 4x from both sides to get 4y is less than or equal to negative 4x plus 36. Divide each term by 4 to get y is less than or equal to negative x plus 9. And we graph that inequality. So y-intercept is 9, and then the slope is negative 1. So we go down 1, right 1 to draw the slope. Okay, so there's our line. This inequality is less than or equal to negative x plus 9. So the area that we care about is below this line. Okay, next let's transform this inequality. 3x plus 6y is less than or equal to 30. We subtract 3x from both sides to get 6y is less than or equal to negative 3x plus 30. And then we divide by 6 to get y is less than or equal to negative 1/2 x plus 5. And then we graph that line. So y-intercept of 5, slope of negative 1/2 means go down 1 over 2. So shading is below this line as well, because our inequality is less than or equal to. So now our last two inequalities just bound our region in the first quadrant. So x is greater than or equal and y is greater than or equal to 0 means that our region ends up being this one that's shaded in green. So that's the region where x and y are positive, and it's the region shaded below both the red inequality line and the blue inequality line. So now we can use the corner point theorem in order to determine where the profit is maximized. Our first corner point is 0, 5. So we plug that into the z function, z equals 90x, so 90 times 0, plus 110 times y, so 110 times 5. That would be 0 plus 550. So the profit at that point is 550. Next corner point is here. That is the point 8, 1. Plugging that into the profit function, we get z is equal to 90 times 8 plus 110 times 1. 90 times 8 is 720 plus 110 gives 830 for the profit at that point. The last corner point is this intercept with the x-axis, which is the point 9, 0. That would be 90 times 9 plus 110 times 0, which is 810 plus 0. So profit there is 810. So the maximum profit in this situation is $830, and it occurs at the point 8, 1, which means it occurs when 8 item x's are created or are produced and 1 item y is produced. I'm going to make one small note that 0, 0 was also a corner point, so really we should have plugged that in, but since we're trying to maximize profit by plugging in 0, 0, we're going to get 90 times 0 plus 110 times 0. So we would get a profit of 0 at that point. But since that is a corner point, really it should have been included in our calculations.